Let's look at this problem that your experiment descriptions and in the circular motion one. The last questions. Question 2. It says a bob spring. What initial force would you feel? So take the bob as a car. If you sit in a car, what initial force would feel? The common mistakes first is to link this question to the Newton's third law. However, we need to notice that Newton's third law is about force and reaction force, which means that, for example, the force is given by A, and A sends the force to B. The reaction force must to B and received by A. Again, a very easy example is that if you are putting a door, the reaction force must be the door, generated by the door, and received by you. So this is force and reaction force, and only under these conditions it will subject to Newton's third law. Okay, so in our lab, our bob is taking the force of the spring, and direction force is the bob also given a force to the spring. So this is, if you are analyzing this, you can use Newton's third law, but obviously you're analyzing something that's in a car, so it has nothing to do with the spring and the bob, so it cannot work. And also, Newton's first law is about the inertia. It sounds reasonable to link inertia with an inertial force, but not that directly, because inertia is just a statement of this motion state of an object. It will be static or keep a straight and constant velocity. It has nothing to do with quantitative inertial force, so again, certainly we cannot use it. So how do we describe we're in a car which is all bob and we're rotating? In fact, that if you look into your daily experience when you sit in a car, it's not just you, but everyone sitting in a car feeling the inertial force. So it is something that imposed on every objects in the system. Which force do you come to if you think about this figure? Well, I think that's the gravity. The gravity are imposed on every object on Earth, so I'm not saying that gravity is an inertial force, but they have the very same features, and you may use an analog with it. So how much is the gravity? It's m times g, right? And m is your own mass. If it's a box, it's m box times g. If it's a man, it's m of the person times g. So m is your own feature. So if you're sitting in a bob or a car, we can also say that it's m times something. So what is something? The intrinsic feature of gravity is g. We all know that. So what's the here about the inertial force? Of course, is the acceleration of the system. And A is caused by the acceleration of the system, but we all know that when you're calculating the force, right? When you are calculating the initial force, it always has the the opposite direction is the acceleration direction of the system, right? So it's the of your frame. So it'll be minus m. So here is our inertial force. Okay, it is determined by the intrinsic feature of the frame you chose. So every object in this frame will be imposed with this force. So it's very similarly to the gravity, that the gravity is the intrinsic nature of the Earth. So and every object is feeling the Earth. So in gravity is m times g, the mass of the object times g. So here it will be m times a. M is the mass of the man, not the bob, right? The gravity is not determined by the mass of Earth, but the mass of you yourself. So m is the m of the man sitting in the bob. And A is the acceleration of the bob. And of course, it is counter direction, so there's a minus sign. Okay, so here's the explanation for the questions in your lab description. If you have any other more questions about it, please email me.